at the problem and say, okay, these have something in common. So what divides into both 12 and 10? 2. Good. And then I need to pull out an x squared because both have an x squared involved. Okay, so we kind of pull this out to the front, and then we have to ask what times 2x squared would get me 12x cubed? 6x. Good. Okay, what times 2x squared gets you 10x squared? 5. Very good. Okay, and that's it. It's factor. So when you factor out the GCF, you do need to remember that this part has to stay in the answer. Okay, the part that you factored out, the GCF part, has to stay there. You can't just write this. So sometimes, we like to write it as like we're dividing by 2x squared, which is fine, but then you kind of tend to leave it off. Okay, and it's like, oh yeah, we divided out by this and there's nothing left. You have to put that in the front. Okay, you can't just leave it off. Okay, why don't you guys try example 2? Factor out everything they have in common there. Take the package. Okay. Okay, so 14 and 28 have 14 in common. And then we have to pick the lowest exponent on each one. So I would take out x squared and y to the 4th. Are we okay there? Okay, so then 14 times what gives you 14? Just 1. X squared, I need 6 more x's here to make x to the 8th. And then I have y. And then minus 2, and I took out everything as far as the variables go, so it's just minus 2. Questions? Okay. Difference of 2 squares, we should kind of remember from last chapter. So it's 2 numbers, both are perfect squares, and it factors into 2 factors. Each of them are the square roots of those perfect squares, one with a plus and one with a minus. So what times itself gives you x squared? X. Then I have plus and minus, doesn't matter what order you put those in. And then what times itself gives you 49? 7. Okay. Example 2 then. Also difference of 2 squares. So we have 2x and 2x because 2x times 2x gives you 4x squared. I need plus and minus, and then 9. 9 times 9 is 81. Okay, something like example 3 might not look like the difference of 2 squares, but it does have a GCF involved. And so once I pull out the 2, then I have 25x squared minus 16. So now look at the part that's in the parentheses. Is that the difference of 2 squares? Yeah, so go ahead. Why don't you guys factor that into 2 factors, difference of 2 squares. He's never in class. I'm like, why don't you go to class? He's here like every period. Yep. Okay, so that would factor into 5x minus 4 or plus 4 and 5x minus 4. Questions? Those can be switched. Okay, we'll skip example 4. I think you guys have this. Trinomials with a being 1. Okay, these were the easier ones to factor. So you need 2 things that multiply to a times c. So 1 times negative 28 and add to negative 3. Okay, so again, if you're not real good about just like pulling those numbers out, maybe you want to write down some things that multiply to 28. So 1 and 28, 2 and 14, 4 and 7. Okay, and then look and say which of those pairs could possibly make 3? So could you add, subtract anything with 1 and 28 and get 3? No. Okay, how about 2 and 14? Ever going to give you 3? Okay, could 4 and 7 give you 3? Yeah, and you need it to be negative 3. If it's going to multiply to negative 20, negative anything, one of the two is negative. Okay, the other one's positive. Which one would have to be negative to make negative 3? Good. So then it's just x plus 4, x minus 7. In any order. Okay. Okay, this one might look pretty complicated, but again, if we stop and think, okay, I got to take out the GCF first. The GCF is 2x, and so I'm left with x squared plus 19x plus 34. Okay, so now you need two things, because I'm just looking at this part. I can ignore the 2x now. I need two things that multiply to 1 times 34 and add to 19. So two things that multiply to 34 and add to 19. There's not a whole lot of things that multiply to 34. Yeah, 17 and 2. Okay, would be the only options here. Do I need to change either of their signs to give me 19? No, they're both positive. So just 2x, x plus 2, x plus 17. Okay, so those are all review problems. Pretty straightforward. Hopefully you remember your factoring. If you're still struggling with these types of problems, I'm not going to be able to tell you this enough. You have to get help with it. You have to. Okay, you're just going to struggle the whole rest of the semester if you cannot pretty quickly factor these problems. Okay, trinomials where a is not 1. These were the ones we traditionally struggled on a little bit, where you have to split your middle term. So I need two things. There's no GCF, so I need two things that multiply to 3 times negative 5, so negative 15, and add to 14, the middle term. Okay, two numbers that multiply to negative 15 and add to 14. So the only options for 15 would be like 1 and 15, 3 and 5. What's going to make 14? Okay, so is 1 and 15 possible, or 3 and 5 to make 14? 1 and 15. It has to make negative 15 when you multiply, so one of them is negative, and they have to add to 14, positive 14. So negative 1. Okay, now I'm going to split my middle term. So I'm going to split this 14x into negative 1x and 15x. Doesn't matter what order. The other two terms just stay in the problem. So negative 1x plus 15x minus 5. Okay, so notice this 14x just got split into these two numbers. I used my magic numbers that I found to work here, and I'm splitting it. We saw a lot of people struggle with this step on the first test of the year. Okay, so now I'm going to group the first two and group the last two terms. What do the first two terms have in common? Just x. Okay, so I'm going to pull on x, and I have 3x minus 1 left inside. You have to remember to put 1 here. You can't just leave it off. Because if you leave it off, that's not going to multiply to give you this. If you put the 1 on when you distribute, it gets you back to here. Okay, what do 15x and negative 5 have in common? 5. So I'm going to pull out 5, and I have 3x minus 1 left. This is how you know you did it right, because the part in parentheses is the same at that step. If it's not the same, go back. You took out something, or you forgot to take out a negative or something. Okay, you didn't get the same answer. So one of the factors is 3x minus 1, and the other factor is x plus 5. Okay, since it didn't have a solve, you can just stop there. That's factored. You don't have to set it equal to 0 and solve for x. Okay, it's factored here. Questions? Okay, why don't you guys try example 2 here? Just so we're all on the same page to start, you need two things that multiply to 9 times 4, so 36, and add to negative 12. Okay, so that's where you should start. And then whatever numbers you get, split your middle term. Okay, I'm seeing a good start here. Most of you got that it should have been -6 and -6, correct? These are the numbers. Okay, I'm going to split my middle term. So I'm going to write it as -6x minus 6x. Because together that makes -12x. Okay, then I just bring these ones down. So 9x squared and plus 4. Okay, group the first two, group the last two. What do the first two have in common? 3 and x. So I'm left with 3x minus 2. What do the next two have in common? Okay, you could try to pull out 2, but then you're going to end up with -3x plus 2. And that's very close to this, but not exact. So I'm going to pull out -2. Because then I'm left with 3x minus 2. You have to be careful with your signs. Okay, if you tried to pull out 2 first, you would notice this is negative and this was positive, and that doesn't match that. Okay, so then I was like, oh wait, I have to pull out -2. So one of the factors is 3x minus 2 from the parentheses, and the other factor is 3x minus 2 from this piece. 3x minus 2 is here, 3x minus 2. Okay, and then you don't have to solve, so you just leave it like that. Questions? Okay, we're going to do some different factoring on the back here. So I'm not sure how much you got into this in Math 2 with the sum and difference of cubes. They probably spent most of their time factoring on the squared problems or the quadratic problems. But probably you've seen it at some point. So factoring sum and difference of 2 cubes just has a formula, and you just have to memorize the formula. There's no way around it. Once you memorize the formula, it's pretty easy to factor it though. Okay, so we're going to figure out what the cube root of both numbers is, and the first factor is going to be the cube root, so a and b, with the same sign as the original problem had. Okay, so since this was plus, I'm going to put plus here, and since this was minus, I'm going to put minus here. Okay, so that's the first factor. The second factor always has the same format. You take the first number that you put here and you square it. So a squared. You take the last number that you put here, this b, and you put it at the end and square it. And in the middle, you multiply those numbers together. So a times b goes in the middle. Okay, same exact setup here. The only thing that changes is the signs. So when you had the same sign first, now you have the opposite sign, and then this is always plus or always positive. Okay, same sign, opposite sign, so this is plus, always positive. Okay, so I'm going to write this over here. I remember it by remembering SOAP. Okay, this is same, opposite, always, it's hard to spell down, always positive. Okay, so that's how I kind of remember what the signs are supposed to be. The same sign, opposite sign, always positive. Okay, every single one of these problems follows that same format. So once you memorize it, you know, it's pretty straightforward then. But it is not super easy to just memorize it, so you kind of have to practice it. It's also very helpful to memorize your perfect cubes, or remember some of them at least. So like 1 cubed is 1, 1 times 1 times 1. 2 cubed, 2 times 2 times 2 is 8. 3 times 3 times 3. Do we know that one? 27. Good. 4 times 4 times 4. 64. 5 times 5 times 5. 125. Okay, 6 times 6 times 6. Now they start to get a little bit tough. 216. 7 times 7 times 7. 343. 8 times 8 times 8. 512. 729. And 1,000. I would suggest that you at least know up to there. Okay, up to 5. These ones get a little bit tough after, but up to 5 you should know without a calculator. Okay, the other ones, you know, we won't put anything on a non-calculator. That's too tough for you. Okay, so that being said, let's practice a couple of these. First, you have to be able to recognize that it's this formula and not the difference of squares. Okay, so the thing that kind of throws this for not being difference of squares is that it's cubed and not squared. Okay, so right away you know it can't be difference of two squares. Also, it doesn't have minus in between, so that would not work here. Okay, so I'm going to take the cube root of both. So what times itself 3 times gives you x cubed? X. Good. What times itself 3 times gives you 64? 4. Okay, so that's like my a and my b in my formula now. Okay, a would be the x and the b would be the 4. Okay, now it started with that plus sign, so I'm in that top section. So my first factor is just x, same sign, the s of soap, plus 4. Okay, now the second factor is always a little bit tough, so I'm going to square that first number that I used, so x squared. Then I square the last number, so if I square this 4, what should go here at the end? 16, and then in the middle I multiply them together, so 4x. Then I can put in my signs. Same sign was right here. Opposite sign, so what should go here? Minus, and then always positive, and it's factored. So the nice thing is, like, once you know it, it's like one step. Okay, you rarely, if ever, go further with a perfect cube situation. Okay, because this part almost never factors further. Okay. Okay, let's try it again. What times itself 3 times gives you 8x cubed? So what times itself gives you, yep, good, 2 and then x. Okay, what times itself 3 times gives you 27? 3. Okay, so my first factor is 2x and 3 with the same sign, so plus in the middle. Okay, second factor, I have to square this 2x. So 2x times 2x gives you what? 4x squared, that's the first term. Then I square the 3, so 3 times 3 is 9. And then in the middle I multiply them together, so what should go here? 6x, very good. Same sign, opposite sign, always positive. Okay. Questions? Okay, I'm going to find those numbers with you in this one, and then I want you to write out the factors. So this should be 5x and 7. Okay, so those are your two numbers that you're going to be using. Write out the factors. See if you can practice and get the signs exact. Follow the same setup that we've been doing. Did you guys do this in math too? No? I didn't think they would probably answer there because you do most of the quadratic stuff. Yep. You got it. Okay, let's see how we did. So we have 5x minus 7. Why is it minus and not plus? Because it's the same sign as the original, and it was minus. Okay, then I needed to square the 5x, 25x squared, square the 7, and then multiply them together in the middle. I didn't leave myself enough room there, sorry. Let me move it over. So we got 35x and 49. Okay, sign-wise, same sign was the minus, opposite sign is plus, and then always positive. Questions? Okay, let's do one more. Let's do this one. The first thing I need to do is pull out the 2, because that's the GCF. That's always going to be your first thing to do. I'll pull out the GCF. Okay, now look at this. Is this the difference of 2 cubes? Sometimes we don't recognize it because of the 1. Is 1 a perfect cube? Yeah. What times itself 3 times gives you 1? 1. Okay, what times itself 3 times gives you 1,000? So 10a and 1 are our 2 numbers we're going to be using here. So we got the 2 out in front, it just kind of hangs out there. Then I have 10a. Should it be plus or minus here? Minus 1. Then I square 10a. So 10a times 10a. 100a squared. Then I square 1. 1 times 1. 1 times 1. Oh, good. I thought you didn't know that. Okay. And then we got 10a times 1 in the middle. So 10a, just in the middle. Okay, sign-wise, same sign, opposite sign. So what should go here? Plus, always positive. Okay. Questions? Okay. Well, I'll skip this one, but if you want to practice it, you should get b plus 2, b squared minus 2b plus 4. Okay. So if you want to practice and make sure you can get that, that's fine. Okay. We would like to pass back your tests and go through them with you. Okay. We didn't really have time on Thursday because you guys were only here for half the class. I was like still talking when the bell rang because I didn't realize it. Okay. So